We present ADIEE, Automatic Data Creation and Scorer for Instruction-Guided Editing Evaluation. Instruction-guided image editing uses a single natural language edit instruction to describe how the image should be modified. Evaluating these edits is challenging because we need to consider the original image and edit instruction at the same time. Traditional metrics measure pixel similarity to the ground truth edits, but it makes high-level visual comparison and semantic alignment to the edit instruction. Methods use clip or dino, which captures high-level visual similarity, but clip have limited text understanding when handling long text with complex attribute object compositions. While vision language models or VLMs have holistic vision text understanding, open source VLMs lack domain knowledge. Proprietary models do better but are costly and closed source. So our question is, how can we train our open source VLM for image editing evaluation? To obtain high-quality large-scale training data, we make a key observation that image editing training datasets can be repurposed as training data for image editing evaluation. Samples in both datasets have original images, edit instructions. Image editing training samples have ground truth edits, and image editing evaluation training samples have edited images to be evaluated, as well as their evaluation scores. We can assign ground truth edit evaluation score 1 and original image score 0, since they don't include the change specified in the edit instructions. We add more diverse training samples by generating more nuanced failure cases. If an edited image is further from the ground truth than the original, it is a failure. We leverage clip and dino features to define this distance, carefully exploiting their strengths while avoiding their weaknesses. We also use image editing models to generate samples. These models fall into two categories: instruction-guided and prompt-guided image editing. The former use edit instructions to generate edits as we described before. Prompt-guided image editing requires two prompts describing the input and desired output. To generate these prompts, a natural idea is to use VLMs for captioning, but we found that captions often miss the intended edit even with heavy prompt engineering. To address this, we fine-tune a VLM on a few hundred manually crafted examples that explicitly include the edit instructions in the input. This significantly improved the alignment between the prompt difference and the intended changes. Beyond editing models, we also leverage multi-turn edit sequence to generate evaluation data. Each sequence starts from an initial image and applies edits step by step. If we pick an earlier image as input and a later one as target, the latter can serve as a ground truth with respect to the edit instruction in between them. We can assign evaluation score to each image in the sequence based on their relative position to the input and target, giving us a wide spectrum of scores with fine granularity. After constructing our training set, we input the original image, the edited image, and the instruction into a VLM fine-tuned with LoRa, and the model outputs a quality score in text. Directly generating scores as text lead to issues such as hallucinations. Instead, we design the model to output a special score token, whose embedding is decoded into a single numerical score. The model is optimized with two objectives: a cross-entropy loss for text reconstruction and the L1 loss for score accuracy, combined into a weighted sum. Our method shows superior alignment with human judgment for image editing evaluation across multiple benchmarks. We also use this evaluator to improve editing models. Recall that instruction-guided models are trained to reproduce ground truth edit, but low-quality ground truths can introduce noise and hurt performance. So we extend the editing prompt with predicted ground truth evaluation scores. This reward conditioning maximizes the utility of existing datasets and helps guide models toward higher quality outputs. Here are some visual results comparing the editing model before and after fine-tuning, which shows the effectiveness of reward conditioning. We also compared them in user study where participants prefer our method in 42% of cases, suggesting clear improvement of our model in perceived quality. For automated evaluation, Clip and Dino report similar scores between methods, but with GPT-4o, our approach achieves an 8% gain, which highlights the limitation of Clip-Dino-based evaluation. For more information, please visit our project page. Thank you.